Hey everyone, so moving into Unit 4, which corresponds with Chapter 4 and 5 of the textbook, we're going to look at congruent figures and triangles specifically, and how you can write similarity statements and look at what is congruent and what would be the same across those similar figures. So for today, we're going to look at isosceles triangles, equilateral triangles, how to classify those, how they're different, how they're the same, and all of that. So there's two ways to classify triangles. You can classify by sides, or you can classify by angles. Okay, so a scalene triangle is scalene, isosceles, and equilateral are your side classifications. Scalene triangle is a triangle with no sides that are congruent. All right, so no congruent sides. This would be an example where nothing is the same. An isosceles triangle is a triangle with two congruent sides. And remember, we mark congruent sides by using tick marks, so it might look something like this, where that side is congruent to that. So if this is triangle ABC, AB is congruent to BC. And then last, as far as side classifications go, is equilateral triangle, which is a triangle with three congruent sides, which is all your sides are congruent. Those all look the same. With isosceles and scalene, you can have variation as far as how they look. But equilateral, all three of these are the same. So an equilateral triangle is also an isosceles triangle because it has at least two congruent sides, but equilaterals themselves have all three sides the same. Okay. So those are your side classifications. Your next ones are angle classifications. So you have acute, obtuse, right, are your three angle classifications, and this has to do with the relationship with the angles inside. So an acute triangle is a triangle with all angles less than 90 degrees. Now keep in mind, every triangle must add to 180. Regardless of that angle classification. But in an acute triangle, all three of those are going to be less than 90. Kind of looks like a right triangle there. Okay, so there's an example. All three angles are acute, meaning they're all less than 90. An obtuse triangle is a little bit different. We can't have a triangle with all obtuse angles. If you try to draw it, you'll see like, okay, there's obtuse. If I draw another obtuse, I'm going back this way, and I would have to go like this way. And so I'm not going to get back around to where I started with only three sides. So an obtuse triangle is a triangle with one obtuse angle. So something like that. And then a right triangle is a triangle with one right angle. Again, having more than one right angle would result in a shape other than a triangle. One right angle, so like that. Okay. So we have acute, obtuse, and right. You can name things with both an angle and a side classification. So you can have an obtuse scalene or a right isosceles. Equilateral triangles are usually always equiangular. And an equiangular triangle is a triangle with all sides the same, or all, angles all angles the same, the same measure. So you have 180 divided by 3, an equiangular triangle, they're all 60 degrees. And because all the angles are the same, all the sides are also the same. So equiangulars are also equilateral. All right, triangle sum theorem. Something that I've already mentioned several times, and some of you have already started using with some of the figures we had in last unit. The sum of all 3 angles in any triangle is 180 degrees. This is referring to interior angles. Right, and we will specify again down here. You can see exterior angles. We'll talk about the difference between those two. So if you have a triangle and we number the angles 1, 2, 3, angle 1 plus angle 2 plus angle 3 is always 180 degrees. And so you can use that fact to find missing angles if you're only missing one of them. Okay, the exterior angle theorem is the sum of the two and they're called remote interior. I'll show you what that is. Remote interior angles is equal to the exterior angle. Okay, another way to think of that is the measure. Okay, so an outside angle is something outside of a triangle when you extend one of your sides. All right, so this is an exterior angle. So the measure of this angle, so we'll call this 4. And we'll number this one the same as above. Is equal to the sum of the 2 angles that are not adjacent to it. So we call those remote. So if you think of like a remote worker, they work from like home. They don't work in the office away from. So angle 1 plus angle 2 is equal to angle 4. All right, so these are your remote interior. Okay, and we could get there with a proof, a fairly quick one. So statements, reasons. We know that angle 1 plus angle 2 plus angle 3, I'm not starting with my given here, equals 180 by my triangle sum theorem. Right. We'll just assume the given is your diagram. Right. Well, we know that angle 3 plus angle 4 equals 180 by definition of a linear pair. I'm really abbreviating here. Okay. So that means that angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4 by substitution Okay. And then we can finally conclude angle 1 plus angle 2 equals angle 4 by subtraction. Okay, so that's what the proof for that would look like. So that's where that comes from. The fact that the relationship between 3 and 4 and the relationship between 1, 2, and 3 are all the same. Okay, so using those to solve algebra problems. So for triangles where you're given all 3 inside angles, we can set up a quick algebra equation adding up the 3 of them. Oh, my pen is not writing today. And setting them equal to 180. Go ahead and solve that. Okay, so x is 28. Well, if x is 28, none of the angles are the same, so none of the sides are the same, and we'll talk about that correlation a little bit in class. But this is classified by angles. So angle classification for this, we have one obtuse angle, so this is an obtuse triangle. All right. So go ahead and try B on your own, and I'll check that in class. Okay. But let's talk about part C. So if we use that formula from above, we know that these two non-adjacent angles to this, so x plus 80, the sum of those is equal to this outside angle. So 3x plus 6. Okay, so go ahead and solve that out. Okay, so x is 37. To classify this triangle, it's a little bit more work, so we know that this angle is 37. All right, so I'm going to take 180 and I'm going to subtract 37 and I'm going to subtract 80 because that will get me what this last angle over here is. Your other option is to plug in 37 for x, solve that out, and then subtract that from 180. So 180 minus 37 and minus 80 is the same as 100 minus 37, which is 63. So this angle here is 63, this angle is 37, and this one is 80. All of those angles are less than 90, so this is an acute triangle, which you can tell by looking to some extent. But you're doing angle classification, so find those angle measures. All right, so part D is the same, so I'm going to have you go ahead and try those on your own, and I will check part B and D in class tomorrow. Have a good night.